So let's solve the system of linear equations by using the inversion method. We've discussed the Cramer's rule before. Now we'll discuss the inversion method. So we have the system of linear equations. Let me just turn the pen on. So we have the system of linear equations, and basically, first of all, you can write the third equation here as 0x plus yz minus 0x plus y minus z is equal to 1, as there really is no value for 0 for value for x. So now in matrix form, what this entire system will look like is basically this. As you know, it's rows into columns. So so the first equation here can basically just be done by multiplying this first row with the variables column. And same is for the other two rows. They'll solve for the other linear equations here. Now, you'll put this equal to this, as these are the constant values that the variables are equal to. Now, you have these matrices. You'll give this matrix the name matrix A. The variable matrix will be called X, and the constant matrix will be called B. So the coefficient matrix A, the variable matrix X, and the constant matrix B. Now, what you'll do here is you have to find the values for X, Y, and Z. So you'll take A on the other side and it becomes A inverse B. So to find the variables to solve the system of linear equations, you must find A inverse B. And you'll call that equation 1. Now, to find the determinant of A, again, you already know how to do this, but just for a recap, you'll basically just, for example, this here. What this is you'll basically multiply this 1 here with its cofactor, and then you'll add similarly -2 multiplied with its cofactor to get this, and then you'll add that with this 1 here multiplied with its cofactor to get this, and then by expanding this you'll get the value of determinant of A as -2. Now, since A is not equal to 0, we can find A inverse. It is a non-singular matrix. So to find A inverse, you basically need two things. You need the determinant, but you also need the adjoint of A. So you can refer back to the video where I explained how to find the adjoint of A. Just for reference, you'll basically make a matrix of the cofactors of each and every element here. Each and every element, you'll find it every element's cofactor and you'll make a matrix of it, and then you'll take its transpose. That will be the adjoint of A. So just for clarification, let's take the cofactor of element 1 here, A11. So -1 raised to the power the row number, which is 1, and the column number, which is 1 as well. And then you'll multiply that with the determinant of the minor of this one. So basically you'll delete the column it's in and the row it's in, and you'll take the determinant of the remaining elements. So this is how you find the cofactor, and that results in 1. So the cofactor of 1 here is 1. And you'll take the cofactor for each and every element in this matrix as such, in the same manner as you've done for the 1 here. And then you'll take the transpose of the resulting matrix. This is the resulting matrix, and you'll take its transpose to get the adjoint of A. So the adjoint of A is this matrix here. Now you'll divide the adjoint of A with the determinant of A, and you get this here. And then, as you remember, X is equal to A inverse, this is A inverse, and this is B. You'll solve this. Oops, my bad. So you'll solve, basically you multiply this matrix here with this matrix to get this matrix, and then you'll divide that by -2, and so you'll get this as the result. So x is equal to 1, y is equal to 1, and z is equal to 0. And that's how you'll solve this.